Hello, welcome to the series on Java. So, in this series, we will be discussing on the Java and the Java platform. And so, we'll start. So, in the early days, computers were looking like this, and the computers were almost filling half of the room. And these computers, for example, what is shown here, ENIAC, and these computers were programmed by special individuals called as paper tape operators, and this is what is a punch paper tape, and the data which should be fed into this computer was fed using these paper tapes, and they were punched using a punch cards, and they were fed to paper tape readers, and these paper tape readers read the paper tapes and did the computations that was required. So these were the um, input centers of the earlier computers. And as I said earlier, these were the first paper tape reader of paper tape operators, and they were also what we call the first programmers. So in the early days were programs like Fortran, COBOL, Pascal, BASIC, and assembly language. So Fortran was actually a scientific programming language which was mainly used for scientific and engineering and military uses. As you see over here, Fortran was also used as paper tapes for or the punch card for processing the data. Another language is COBOL. So COBOL was actually developed for business and financial and administrative systems, and it was used by huge corporations and by the U.S. government as well. And COBOL is still used widely in applications which are deployed on mainframe systems, which have large-scale batch and transaction processing. And still, COBOL developers are in much need since it is a niche field. Another language is Pascal. Pascal also was a pretty simple and lightweight language during that time, and it was developed in the year around 1970s. And basic, maybe most of you might have heard about basic language. I started programming basic, and it was taught in schools basically mainly because basic was for students who did not have strong understanding of mathematics or computers or scientific calculations. And basic was further developed by Bill Gates and Paul Allen, and the founders of Microsoft, who made the first marketable product of their company using BASIC. And there was assembly language, which was used basically for writing code which was understandable to the machine rather than for humans. So if you see over here, the code is not much user friendly. It is more machine understandable code. So the problems with these languages were that they were not portable. So what we mean by portable is if you write the language or the code in using this language in one platform or operating system, it could not be ported to another environment or a operating system. So there should be compilers written for each and every specific platform. Second was it was unstructured code, so the code was difficult to understand for a new person who joined the team, and the code often led to a spaghetti ball of code because it was not structured, and it was a maintenance nightmare for the newcomers as well as the uh, seasoned developers. So, and some of these languages were also low-level coding, like the assembly language, and it was pretty difficult for people to work around them. And it was also not easy to write business-specific code using these languages. So to address these issues, then came the era of the C programming language, and C was a general purpose programming language. It was developed by Dennis Ritchie at Bell Labs, and it was released in 1972. And it's C actually supported procedural programming and structured programming, which was missing in these early programming languages. And during 1980s and later years, C gained much popularity, and it has become one of the most widely used programming languages, with C compilers from all vendors for majority of the computer architectures and operating systems. Even though C was great and is still relevant for writing high performing code, C missed some key features like object orientation or function programming, etc. And if C code was not written carefully, it caused memory issues because the C language didn't provide a garbage collector out of the box from the language platform itself. So to give more ability to C, then came the C++ or the object-oriented C. So C++ was developed by Bjorn Stroustrup, and it was actually first named as C with classes, and it gave object orientation and functional style of coding to C, and it was used for system programming and embedded and resource constrained software for large systems, and it provided high performance and flexibility for much of its use cases. So during that time, at Sun Microsystems, a group of engineers who were led by James Gosling initiated the Java language project in June of 1991, and it was initially named as Oak, and later they changed the name to Green, and finally it was renamed to Java. And Java promised from the beginning itself that it would be platform independent. So if you wrote code once and compiled it, it could be run on any platform. That is what write once, run anywhere. So the Java code you wrote and the bytecode which was generated could be run on any platform, irrespective of on which platform the code was compiled. And when we talk about the design goals of Java programming language promised to be simple, object-oriented, and familiar. So familiar, it meant that it would be looking mostly like C or C++, so that it wouldn't give much of a learning curve for the developers of that age who were writing code using C and C++. And it also provided object orientation, which was present in C++, and it would also be write simple and clean code using Java. The next design goal of Java was that it would be robust and highly secure. So Java is being used in much of the distributed environment, so security is of paramount importance. And the robustness of the language is provided by its high static checking and compilation checking and second level checking at the runtime as well. So this provided the robustness to the language as well. And next is it was a architectural neutral. So as told earlier, it promised that Java program, if you wrote anywhere, it could be ran. If you wrote once, it could be ran anywhere. So that was what is meant by architectural neutral. And the architectural neutral and the portability of the language is actually provided by Java platform by a technology called as Java Virtual Machine. So Java Virtual Machine is what provides this architectural neutrality and portability for the Java platform itself. Next point is the performance of Java code. So from the beginning itself, Java code was meant to be ran on multiple different platforms, and there were multiple different stakeholders over here. So it provided high performance on all the platforms, irrespective of the code being compiled on any platform. And the last point is interpreted, threaded, and dynamic. So this is for a discussion at a later point of time. And with this, we come to an end with this discussion on the beginning of Java. We will be releasing other videos on the further developments of Java and the Java platform. Hope to see you in the next video. Thank you.